In this lecture, we're going to learn about inline functions. And this is a facility we have in C++ to avoid the function call overhead on our functions. What do I mean by that? Let's look at a simple illustration here showing what happens when you click on your application binary to run it. Suppose this black thing here is your application binary, the executable you have somewhere on your file system. You double click on it to run your application. When you double click on it, it's going to be loaded by the operating system. And the operating system is basically going to load a binary representation of your application source code in memory. So that's what is going to happen here. The binary is going to be loaded in memory, and you see that we have a representation of our program here, somewhere in our memory map. Once the program is loaded in memory, the CPU is going to start executing. So it's going to go on top here. It's going to see a equals 10. It's going to set up a variable on the stack, and it's going to store in a 10, which is what we see here. It's going to set up the b variable somewhere. It's going to store in a 5. It's going to set up the c variable, and it's going to put in some junk data because it's not properly initialized. Then it's going to print some things. It's going to print statement 1 and statement 2 on the console. That's what we see here. And then it's going to see a function call. Here we are saying call the function add, and you're going to add up a and b, and the result of that is going to be stored in C. What the CPU is going to do when it sees that, it's going to see that the function lives somewhere else, and the function address is somewhere here. You see, this is 0030, and the function call is at address 006 here. Once the CPU sees that it is going to jump to another location, it is smart enough to set up a location where it's going to return when it is done doing whatever it does in the function. So it is going to say, I am at address 6, so my return address should be 007 here. So for example, it's going to store its return address to be 007. That's what it's going to do as we see here. After that, then the CPU is going to jump to the function location. It's going to do whatever it does. It's going to add up a and b, and it's going to put the return value in C, and then it will need to return to its address, and it is going to execute the statement at 007 here and print statement 3 and statement 4. Hopefully you can see that this is a lot of overhead just to call a function. And sometimes our functions are really simple compared to this overhead, and we don't want to go through the overhead to call functions. That's why we have inline functions. Suppose we have a function here called max, which is going to compute the maximum between two numbers. And if we call this function, for example, in an output statement here, we're going to go through the function call overhead we just described. If we don't want this overhead, we can give a hint to the compiler to mark our function as inline. And the way we do that is to put the inline keyword in front of our function here. This is going to suggest to the compiler, if possible, please inline this function. And what inline means is to expand the function in place and avoid the function call overhead. And the way this is going to work, when the compiler sees the line here to call the maximum function, it's going to take it out, and it's going to put in a representation of our function call in place. And this is going to be done in a way that we're going to get the same output, but we're going to avoid the function call. If you see here, this is a simple representation I came up with just to try and explain this. Please don't think that this is how the compilers are going to do it. I haven't checked how compilers do this, but this is what inline means. The compiler is going to expand the function in place, and it is not going to call the function. It is basically going to take the code inside the body of your function, and it is going to put a representation of that at the point where you are calling the function. So here you see that it is saying if value 1 is greater than value 2, then print out value 1. If that's not the case, you're going to print value 2. And we are basically going to get what we would have got if we called this function here, but we are avoiding the function call overhead. Hopefully this is really making sense. Okay, one thing you should know is that the inline keyword here is just a suggestion to the compiler. So the compiler might just ignore you if it sees that doing the inlining stuff would complicate stuff. It would completely ignore you and still use the function called overhead that we are trying to avoid here. But if the compiler does that, it is going to expand the source code in place, and you are going to avoid the function call overhead. Another thing you should notice is that because this source code is basically going to be copied over in every location where you are calling your function here, this is going to drastically increase the size of your binary. Because the function is basically not being reused, we are copy and pasting it every time we call the function here. This is another thing you need to be aware of. Okay, here are a few things you need to keep in mind in terms of inline functions. They can increase the size of your application binary because the compiler is going to be copying and expanding the function in place. So this is going to increase the size of your program. It is recommended to use inline functions for short, frequently used functions. And you, the developer, should really do your own analysis and see if inline functions help or don't help your application. And the last thing which is really important is that marking your functions as inline is just a suggestion to the compiler. The compiler might agree and inline your function and expand that in place and avoid function overhead, but sometimes the compiler is going to just ignore you, and this is something you need to be aware of. Okay, now that we know this, let's go to Visual Studio Code and try and really make you understand this a little more. I have to say I don't have a way to show that the compiler actually inlines the code, but you'll have to believe me on this because I don't really have a way I can show you this. Let's head to Visual Studio Code and play with this a little more. Okay, here we are in our working directory. The current project is inline functions. We're going to grab our template files pretty quick and we're going to put them in place. And we are going to open this in Visual Studio Code by dragging and dropping here. Okay, we have our main CPP file. We're going to clean it up a little bit here and we close the pane here. And we are going to put in our function, which is going to compute the maximum between two numbers. Pretty simple. We have seen this function like 1,000 times. But every time we call this function, we're going to be going through the function called overhead. And this is a really simple function. So the function called overhead is basically going to be eating a lot more CPU resources than the function call itself. And sometimes we don't want to pay this function called overhead price, but we want to keep the flexibility of organizing our code into functions because that's easier. As we have seen, a solution to that is to mark your function as inline and give a suggestion to the compiler to expand our function here in place. And if, for example, we go down and say int a, for example, and put in a 5, let's set up two variables and say int b and put in an 8, why not? And we try to print the maximum between a and b. We should do something like this. So we're going to say max a and b. We pass these guys by value, no problem. And we set up our stdcout statement like this. If we build this program, it is going to build and run fine, no problem. But every time we call this function, we're going to be doing the function called overhead. Let's bring up a terminal and show that we are actually getting the maximum. Let's bring up a terminal. That's what we want. And rooster, we're going to get 8 as the maximum. But if we mark our function here as inline, the compiler is going to basically expand this in place. And what the compiler does, if it agrees to inline your function, is to avoid the function call and still give you the same result. So what it is going to do is something similar to what I am about to show you, but I am not saying that this is exactly what happens. It is just a simple example I came up with to help you understand what inlining is all about. If the compiler expands our code in place, it might do something like this. So it might say stdcout max and put a semicolon here. And then it's going to put the equivalent of what we have in the function here in place. It's going to basically copy the body of the function. It's going to go in and paste that in and replace whatever you called your function with here. So we call the function with a and b. So that's what it's going to paste in here. But notice that the body of the function was basically copied and pasted in here. And now that it is doing this, it's not going to return because we are not interested in returning. We are interested in printing here. So it's going to print a. So it's going to say std cout a. Let's put in std and l here. And then if the maximum happens to be b, it's going to print b. Let's do that. And if we run this code, we're going to exactly get what we got when we were calling the function here. But notice that we are not calling the function. The logic was brought from the body of the function to the exact point where we tried to call the function here. This is something the compiler might do if it inlines your function. Inlining means avoiding the function call overhead and expanding the function body in place like we are doing here and still get the same logic and behavior we had if we called the function. Okay, now that we have this, let's try and build again and see that we get the same result. See if I got this right. The build is good. We can clear and run rooster. Now we see that we get the same thing. Max is 8. And if we change, for example, for 8 to be 15, we can do that and build again. We should get max is 15. Run rooster. Max is 15, but we are avoiding the function call overhead. This is really what inlining your functions is all about. Okay, let's put a simple description of the code here. Okay, and hopefully this is really clear. And this is really all we set out to do in this lecture, showing you what inline functions are all about. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about recursive functions. Go ahead and finish up here and meet me there.